Okay, so how's everybody doing? You all done assignment 5?
Yep.
Yeah. Was it easy? Yes. And you've all tested it with inputs that contain millions of elements, and it runs in a second or two? Yes, okay. Yep. It's due whenever it says it's due on See You Learn. I think it's Wednesday morning. Yeah. Okay. So any questions for me about that assignment? Yep. Sorry, you'll have to talk loud.
Actually, in the anagrams, the output for the arrow have three word, three phrase shift. Does that matter? The output is the same, but he have three.
Yeah, that's probably, it's probably just that there was a slightly different data file or maybe a slightly different version of get words. So I wouldn't worry about it if it's just, if it's off by 3 or something. That, yeah, it's probably just caused by slightly different input. Yeah. Yep.
On the spell check, did you remove punctuation from all the letters, right?
Yes.
Because I'm getting a lot more errors, like variable, than you were.
Well, are you getting things that are, it's basically if you're getting a lot of things and they're all not in the dictionary, then you should be golden. Yeah, so it should be fine. Okay. Yeah.
For the bonus question, the second output is totally different. The output from the bonus question. The first output, when you're typing the first example is having the same answer.
Yeah.
The second one is
So it could be totally different because my output is truncated, and I used this. I don't remember. I think the order that I have them sorted in, if it's sorted at all, is maybe by the lexicographic order.
Right, but you're still missing something on the second example. Your output, your result is not fully. You're still missing some word for that.
What do you mean it's missing some words?
I have the second example, right, for the bonus question.
Yeah. So what's the second example?
Yeah.
Which word?
Some word.
SNAK. When you use SNAK,
Yeah.
your example gave about 4, 3. Yeah. But when we got our output, it was about 7.
7, 8.
7, 8. Yeah.
Okay. Maybe the example is shouldn't have been just 3. There's like SNAK. There's soak and snack, snake. Yeah. Okay. So if you get more and they're all in there, then great. Yeah. Okay. All right. So so last class we were working on this bibliographic search application, and we'll come back to that in a second. But we're coming up on a time where things are going to be lean in terms of work for you guys to do. So in particular, there's no assignment next week. You'll just prepare for the midterm, and hopefully you've all noticed that there's a sample midterm on the course webpage. So the actual midterm will be similar to that. There's no need for you to get all stressed about this midterm. The goal isn't to kill you on it. It's a fairly easy thing. If you've been doing the assignments yourself and you understand what you've been doing, then the midterm should be fairly straightforward. There's a couple of questions that have to do maybe with inheritance in object-oriented programming that we haven't really done an assignment on, but you can see them in the midterm exam, and we've covered that material in class, so you can figure those out and be prepared to answer similar questions on the midterm exam. And then after that, we're going to have, after the midterm exam, we have 1 week of class and then a break again. So again, this is going to be a lean time. There'll be an assignment due, but it'll be an assignment that you have sort of 2 weeks to do. It'll be the appropriate length to do in 1 week, which means either you'll do it during the break or you'll do it during, if you want to go on vacation during the break, then you can do it before that. But what I want to talk a little bit about before we jump back into the same lecture as last class is a preview of what's coming up. So after the midterm, we start to do some more sophisticated stuff, and we'll start to do, well, most of us anyway, will start to do programming for game development, and not for these little terminal type games, but actual games with graphics. Or web games is an option too for some of you. So if you're really keen and want to look ahead because there's no assignment to do, we'll be using the Pygame module. And so I hadn't used it up until yesterday. So I spent yesterday afternoon hacking around a bit, and it's fairly easy to use. So you download it from somewhere else. If you're running Linux, you can just install it out of one of the repositories, and it's a module that makes it easy to do graphics, especially game type graphics, as well as sound and a few other things. So, for example, just in the first half hour of hacking around, I wanted to just try out some of the features. Python. Okay, so first thing you want to try out, and many games are sprite-based games where all your characters are little images and you move them around. So I wanted to see how easy that was to do, and that's trivial. That's like the first example in the tutorial. So moving these things around is easy. Doing text is also easy. Placing it wherever you want. Sounds are easy. So there's a sound playing, and sort of animations are fairly easy too. And by easy, I mean relatively easy. So there's some work, and it wouldn't be easy for somebody who'd never programmed before. But you guys aren't those people who've never programmed before. You've been programming now for a month, a little over a month, and so this stuff will be doable for you. So that's just a half hour of playing around, and then I spent another hour or so starting to recreate a game that I used to play a lot in arcades as a kid, which was, you may have heard of this game, Missile Command. So I don't have incoming missiles yet, but there are 3 bases that launch missiles. And that's, an hour and a half of work to get that up and running. Might take some of you longer than that. It might take some of you even faster to do this kind of thing. But this is, this is the level that we'll be working at, and you can put in as much or as little effort as you want into this and make your games as fancy as you want. So I encourage you to, if you're interested, go and have a look at Pygame and the kinds of things people do with it. And we'll have a first assignment, which comes after the midterm, which is sort of a cookie cutter thing, doing 10 different kinds of things just to get you used to this, and then we'll start having more freeform and more complex things. So just a preview of what's coming up to maybe keep some of you motivated. Okay, any questions? Yeah.
How would I do that?
So I've thought of you. So one of the things that one of the main sort of learning objectives of using something like Pygame or what's it called, the Tickle library. What is it called? I forget what it's called. Anyway, it doesn't matter. Is event-driven programming. So unlike the programming that you kind of have been used to, where you're just taking one step at a time, the code just executes, one step at a time. You're totally in control of the flow of things. Event-driven programming is a different style of programming where you write a bunch of code that just sits there and waits for something to happen. Waits for the user to click, or it waits for a timer to tick and tell you to refresh the screen, or any number of things. Another thing so that's the sort of learning objective that I want for this. And another way to get that is to do web programming. So as an alternative to doing these game development assignments, you can do the same or similar kinds of assignments using web programming, where what you actually make is a web server program that has to respond to events. The events are page requests for pages and so on. So that will be the way you can do that. Would you have to do it in Python? Yes. Yeah. Yeah, and hopefully only a small number of people would choose to do that, because there'll be a whole separate marking thing for that. So if you have a good reason to, go ahead. You can choose that, but I don't want everybody to. I don't want to have half the class doing different kinds of assignments. Okay. Good. So that starts after the midterm. I'd love to start showing it to you now, but I think that would just mess you up for the midterm exam. So last class we sort of stopped here with this picture. We were working on this system we were thinking of doing that was to have store this big bibliographic database that holds every computer science paper ever written, or information about every computer science paper ever written. And we started modeling this using an object hierarchy, and we realized there's sort of, on one side, there's people involved in this system. So there's a person class, and there's at least two kinds of persons, authors and editors, so subclasses of person. We also saw that really the system revolves around publications. So a publication is something like a paper or a journal article or a technical report or a book. And so all of those things we have this publication class, and all of those other things are subclasses of publication. And then there's a few other sort of things in there. First name and last name, we decided maybe they're best to be strings. They're part of the person class. And for all of these other types of publications, there's different things that we have to tease out based on what kind of data is associated with each publication. So, for example, a conference paper has a conference associated with it, and it probably has some page numbers, and it probably has authors, an author list, and so on. So one thing that's actually useful in all of these things will be an author list. Okay. So we end up with a lot of classes this way very quickly. And when you do this kind of modeling, it can become overwhelming. So if you decide, okay, these are the classes that I need, and before I can start doing anything, I have to write all of these classes, then you're probably just going to give up, throw your hands up in the air and give up at that point. And there's another problem with working this way is you may later realize, wow, I wrote a class called first name, And that was really not necessary because I don't do anything with that. That class doesn't do anything other than store a string. So there's nothing wrong with prototyping your application or starting it where you don't necessarily have all these classes implemented, and you just cheat a bit on some of them by doing things like just using a string instead of a whole object, just to get things going, or just supporting not all of the possible publication types, but just one or two. So I got this started in the last half hour or so before class, and so we'd seen we had this already, this back-end library that's able to load this bibliographic information. Last class we had made persons, we had made authors, we had made editors, and one of the things that seems useful is this author list. So I made one of those, and an author list is exactly that. It's a list, meaning a Python list, and it contains a bunch of author objects. And it doesn't do much more than that. You give it a list of authors to initialize it. It saves those. This is just saves a copy of the list that you give it. And it's able to turn itself into a string, because author lists appear on a lot of different types of publications. They appear on papers, they appear on books, they appear on journal articles, whatever. And an author list can print itself, and the way it prints itself is it prints the first author's name, and then it repeatedly prints a comma and another author's name. Okay. So that's a fairly standard recipe for printing a list of things. You print the first thing and then repeatedly print a comma or some separator and the next thing, some separator and the next thing, some separator and the next thing. You end up, this is a sort of a pattern that you have this way of doing things, so you should remember it, because it solves this common problem of when you print a list of n things, there's actually n minus 1 separators in there. So there's no nice easy way to do it where you just print, you know, every name with a comma after it, then you end up with an extra comma at the end. So all of this, the easy things you try don't work, so you have this funny way of doing it. And we can check that out. Here we are. Just make sure our classes work. Anybody remember the error? Authors need a list of works. I'm starting to regret that decision. So we make 3 authors, me, you, and him. Who all have different names. And now we can make an author list containing him, me, and you. If I print that author list, oh, I get an error. Anybody see the error? So it says it's on line 38 in __ string. Yeah. Self.authors right there. That's a pitfall of doing a lot of programming in Java, is I'm not used to putting self in front of every single variable reference. Java doesn't require that. Okay, so it prints this this author list the right way. Okay, So we got that working. So I've also made a publication class because that's sort of the root of the hierarchy. It's the central thing. And the only thing that I could really find that is common to every kind of publication is that they have titles. So I can't think of any kind of publication that doesn't have a title. So that should be a property or an instance variable of the publication class is this title. And so when you initialize it, you give it a title. And I chose to implement one of the subclasses, which is article. This is supposed to represent a journal article, and they actually have a lot of information associated with them. They have an author list, they have a title, they have a journal name, they have a volume, they often have an issue number, page numbers, and a year of publication. So an article is a fairly complex, rich piece of information. So the function that initializes it takes a whole pile of arguments. And in fact, you see that I abbreviated the names here in the arguments. There's no reason to do that except that I wanted them all to fit easily on in 80 lines. I really don't like to have to break lines unless I really need to, and especially if all it is the arguments to a function. So I just shortened those. No need to. And then the init function uses this mechanism, this super mechanism. What does it do? So when I do a call to super blah blah under dot init, what's that really doing? So it's calling a function called init. Where is that function defined? Yeah, it's called in the parent class. And actually, I see a bug. Anybody see the bug?
Yeah.
Yeah.
It's the object. It should be a publication.
Yeah. So the article class should be a subclass of publication, right? So here's this article class down here. Should be a subclass of publication, and publication, of course, it's just a subclass of object. Okay. So very quickly we can test that out, see if it works. All right, and now if I try and create an article, so what does it need? It needs an author list, title, journal, volume, number, pages, and year. Title. Journal is research. Title, journal, volume, number, pages, and year. Okay, volume is 3, number is 1, pages is 23,000, 234,000, something to and the year is 2013. Of course, it didn't like that. It says title is not defined. Let's see what we did wrong. TIT. TIT. And that's in line 50. Yeah, right there. Should have told me that before we started. But now it's just a cut and paste job. AL is not defined. Yeah, there's why. Okay, and so that seems to work. We were able to create that thing. And then there's a string method that converts this thing to a string in what looks like some standard bibliographic form. It prints the authors, followed by a period, then the title, then the name of the journal, then the volume, number of pages, year, and so on. So we can test that just by printing the article. Unsupported format, index 24. Right there. Okay. Okay, so it prints it in some reasonable looking way. Okay, so now we've got a couple of skeleton, some of our class hierarchy done. Let's start using it. And we saw that there's this bib app object which initializes itself, and it uses this third-party library to open up a directory, and in each file in that directory, it opens it and reads those bibliographic entries. So that looks like this load bib method. And what I've done here is it goes through those entries, and if there are articles, then it calls load article on them. And what does load article do? Well, it tries to get the author list, and then it returns a string. So that was the default behavior before. But now that we have an article class, we would like this thing not to return a string. We'd like it to return this structured data. We'd like it to return an article object. And similarly, the author list, it used to return an array or a list. Now we'd like it to return this author list object. Okay, so this little bit of code here, which looks at entry.persons. So entry is something from this third-party library. So it gives you a list of strings which have authors' first names and last names. You get them out this way by using a.last and a.first at different indices. So a.last is an array of last names, and a.first is an array of first names indexed by 0, 1, 2, 3, and so on, as many as there are authors. So we want to make an author list out of this. So what do we need in order to make an author list? What do we need to create? No idea? What's that? So an author list takes an argument, which is, well, we've made one here. Yeah, it takes a list as an argument. What's inside that list? Yeah, so an author list takes as its argument a list of author objects. So we need to make a list of author objects. So let's do that. So I want to return a list. Well, I don't want to return this. Let's say let's make a list first. And it should contain authors, a.last. And the way you make an author is you specify their first name, and you specify their last name, in persons. Okay. So that gives me a list of authors. So this funny a.last at 0, a.first at 0, that just comes from this third-party library. That's the way they like to do things. But we just want to make those into authors, and the way we make an author is just specifying their first name and last name. So that gives us a list of authors. And now we want to return an author list object that contains that list of authors.
Don't you also need a list of words for the author?
Yes. So right now we don't have enough information. We won't be able to fill in that list of works until we've loaded every piece of data, but we still want an empty list for now. Okay. So now we have this get author list that's doing the right thing. It's returning an author list. Now load article. So when we say get author list, we're going to get back this author list. Now load article is supposed to return an article, not a string, and so we want to do that. Return an article. Now what do we have to specify for an article? Well, we have to specify the author list. We have to specify all of these other things, which are, and actually to avoid a annoying issue, I will do this. No, I'll leave that out for now. So the authors, the title, so that's all contained, that's all information that was pulled out by this third-party library. It's stored in a variable called B right now. Those are the fields of the entry. And what did we have? Volume, number, and pages, and year. Okay. Yep.
You get author list. When you do AL is equal to author, you have an extra parenthesis after the first square bracket.
Right there. Okay. Good. And so that should return us an article that has what we want. And I'm just going to do one little thing because I'd like to get as many articles as possible. Some of them don't necessarily have volumes or numbers associated with them. So let's see. No, I won't care. I'll just let that go for now. Okay, so now I load this bibliography. It loads all these articles, and it appends them all to one giant list. Let's see how we're doing here. Okay, so loaded 360 publications, and we have them all stored in a thing called B. That's my bibapp object, and B has a list of pubs. There it is. That's a bunch of article objects. And if we look at some of those objects, they're all articles. And if we print them indeed we get a nice representation of those things. Okay, and so there's a lot going on here. When I print b.pubs, b.pubs is an article, so that's converting that article to a string. How does it convert that article to a string? Well, it takes its author list and converts it to a string. That's this thing here. And then it has to take all these other things and append them all together. So there's a fair bit of code executing here. We're testing out both the author lists objects and the article objects, and getting what looks like a reasonable representation of them. Okay. So, well, what should we do next? Well, we would like this thing to be an application for, let's say, searching through these things and maybe organizing these things. So we can work on the search function a little bit. So I'll put that in there. And what does the search function do? Well, it lets you search in different ways. You can search by author, by title, maybe by journal, and so on. And so, you know, this is a piece of code that's cribbed out of the example program that we've done previously, or out of assignment 4. So it partitions this raw input into the search type and or the search command, and then the query. So let's implement maybe a search by title. So okay. So if we want to search by title, how would we go about implementing that? So we have a giant list of publications. In this case, they all happen to be articles at this point. So how would we do a search by title? So somebody gives us this query, and we want to see if it's in any of the titles, or we want to return a list of all the papers that have that query in the title. So many of you have done this, I hope. How many of you did something like this in assignment 4? Okay, so I know that there's a good fraction who didn't submit assignment 4. Probably about 70 people out of the 300 in the class didn't submit anything. So maybe you haven't done it before. That's why we're doing it today. And how did you do it? So you had a list of tracks and you searched for, you know, something in there. How did you do it?
Opening it.
Made a big list of all the tracks.
Yeah. So we've done that. We've made a big list of all of the articles. It's called pubs. And so with that list of all the tracks, what did you do when someone gave you a query? Okay, so you would like a list that contains all of the articles that have the query in the title, right? So let's keep saying that until it turns into code. I would like a list that contains all the articles A if A contains the query, right? That sounds reasonable. So I would like to say that my research results are, let's say, articles for articles in publications if what? if query in A. Now, can I ask if a query which is in a string, can I ask if that's in an article?
Okay, yes, it's like okay,
A dot title. Okay, so A dot title is a string, and I can ask if the query is in the title. And probably I would like to lowercase the title because I lowercase the query, and I should maybe lowercase the title too. That'll avoid queries being case sensitive. So that gives me a list of results, and I can say for R in results. So that list contains articles, and well, let's make it a little bit more nicely formatted. Let's say for I in range len of results, print percentage %d yes one and results at I. All right, let's try that. Okay, so the only thing we've implemented is a search title. So there we go. I search for expected, and I get 13 results. And let's see, optimal expected case, expected optimally, optimal expected case. So there's many duplicates in here. Expected maxima. There's a lot of these Araya, most papers. Expected maximum degree. So that seems to work. Let's try another one. Maybe points. Points returns 3 results. Enclosing K points. Imprecise points. And diagram of points. Okay. Okay. So now we've seen how to do that for title. Let's do it for authors. So then what does the answer look like for authors? Or what's the code look like for searching for an author?
I have a question. What does C dot partition do?
C dot partition? So C is a string, right? We got it from raw input, so we can just look it up. String partition. Split the string at the first occurrence of sep and return a 3-tuple containing the part before the separator itself, and the part after the separator. So in this case, the separator is a space. So when we do partition, it splits it into some stuff that's not a space, and then the rest of the string.
Okay.
And for our queries, that's what we want. We have the command that we type in, and then the other stuff. So we could do this a little bit more tidily, or a little bit more robustly would be to strip off the white space, maybe before and after. That's probably not really part of the query. And if we knew about regular expressions, we could do something a little bit better than partition that would do a slightly better job. But we don't have to worry about that. Okay. All right, so I'm searching for an author. How do I get that?
Should be the same.
So it should look the same, right? I want to go through the list of these things, and except that the condition is different. So it's not that I want to check if the query is in the title. I would like to check if it's in the author list, right? So like this. So let's think about this for a second. A is what kind of object? It's an article. A.authors is what kind of object? It's an author list. So does it make sense to ask an author list to convert itself to lowercase? No, author lists don't support that. So we could instead iterate through the author list, the actual list of these authors, and see if we find it in there. But there's a sort of shortcut we can use for that, and that's just by converting the author list to a string. Right. So if I take my author list, convert it to a string, I know what that does. That prints a nice list of authors with commas between their names, and then I'll just check if the search query is in that list, or that string rather. That will do that. Okay. See if that works. Jump. Oh, not the ASCII codec error. Oh, I can't stand that error. It's an annoying Unicode error. So it comes from the fact that that these things are Unicode, and so there's an author's name that has a funny-looking character in it that can't be displayed on my terminal, and so this this throws an annoying error. Might be able to fix that up here. I'm not sure though. Yeah, so Unicode is this great standard that's been developed for representing characters from every language known to man. In fact, there's this really good web page / Google Plus group which sends you funny Unicode character of the day. And there's all kinds of things, you know, man standing on his head. There's a picture of a man standing on his head. That's one of the characters in Unicode. And it's, you know, great because now every language can be represented using this. Problem is, when you try and display them, not every font set has all 60,000 Unicode characters available in that font, and so you get errors when you do this. So we'll do that. We'll hopefully avoid that. So search author, DeVry. Okay. All right, and so now we get a list of articles, and if we look, indeed, we see a DeVry there, and we see a DeVry there, we see a DeVry there, there, and so on. Okay. So see any issues with the results that we've been getting? So they seem to be correct in that we're returning all of these things, but see any issues there? Yep. They're long and go into other lines. I don't want to have to deal with the formatting of them, although I guess we could. We could probably do that fairly easily. I don't know. You want to see how to make strings not be too long. There's a fairly easy way to do that. So we'll turn results at I into a string. What? No. And I don't know, what are we worried about? Strings that are more than 60 characters long? Maybe we'll truncate those. Let's say s equals s up to character 25. Some dots, and then s from character minus 25 till the end. See if that does it for us. What's that? Oh, yeah. Yes. There we go. So there's a shortened version of the results. Not as much information, but they're at least nicely formatted now. But they actually, maybe the problem stands out a bit more now. That's okay. Well, that's a function of shortening the strings, and we'll leave that alone for now. That's fine-tuning. But any other issues? Yep. Yeah, that's fine. That's because we wanted it to fit. But there's something more fundamentally wrong with the results, maybe. That we seem to be getting duplicates. So I don't know. Here I see Avis and Beersford and Avis Beersford. So there seems to be some duplication happening here. So we need to clean that up a little bit. So there's something on our to-do list. How about, well, we might as well do a couple more of these. Well, actually, they're not. They just happen to be. Well, this one and this one is. This one and this one I know for a fact are not. They're just formatted differently. So one has full names in the thing and one doesn't. So we'd have to play around a lot with that to get those to unmatch. Maybe we can take authors' names and put them in some canonical form instead. That might help. But let's, I mean, here's clearly a mistake in one of these bibliographies because these are the same article, but the years are off. So there's some errors in there, and a big part of these kinds of applications is cleaning these things up. Let's just finish off a couple of these queries. So what if I want to do a search in a journal? What's that one look like? Is journal, well, let's see. So it's going to have this form. And what needs to change here? This is the code for searching in a title. What do we need to change? Yeah.
A.title to A.journal.
Yeah. So that's an easy one. Rather than looking in the title, we'll look in the journal itself. And here's another one. What if I want to, S, I guess, is supposed to be a search in all fields. How would I do that? Any trick to do that? Yeah.
Why would turn all if elif statements into a function and then just call that function again with the same query or the different commands?
Okay, so you could do that, but there's a shortcut that we have available to us. So what I'm looking for is some text in anywhere in any of these fields. Yeah.
Could you just convert A to a string?
Yeah. So it just happens that if I convert A to a string, I get all of those fields, right? It prints out all the information about A. So if there's text in any of the fields I'm interested in, I'll find it in that string. Okay. Then we can. So I can search for a journal with computational in its title, and I get a bunch of results. You don't get to see the journal name because of the way they're formatted now. I can search in everything for, well, let's try Segal. I get some articles by Segal. Let's try Geometer, and I get a bunch of things, and these probably mostly come from the Journal of Computational Geometry. So maybe this shortening of results is not so great for testing. So let's just cut that out. Now, we can go a little bit beyond the sorts of things that we've done in the assignment. So, for example, if I do a search for, let's say I search for authors, and imagine you're using Google or something, and you say something like, my query terms will be, I don't know, let's say Bose. That gives me a bunch of results, 48 of them. And let's say SMID. That also gives me a bunch of results. And now what if I query for Bose SMID? So intuitively, what should the result be? That's what we'd like, if it has both Bose and SMID. Is that really what's going to happen here? Yep.
No, because it has junk after the third.
It has junk. What kind of junk?
Like in your code, it will only take the Bose.
Well, no, it won't only take the Bose. If it only took the Bose, we'd get lots of results. It takes, yeah, so it's literally searching for Bose space SMID. And so I think we could maybe get this to return some results if we did something like that. Then we'll get it, but that's kind of a lot to ask a user to do. If they're looking for all the articles authored that have both Bose and SMID as authors, that this is not a way to get them, because if there happened to be another author whose name fit in between those two, you wouldn't get them either. So, so let's say we want to do this sort of fancier kind of search, that when someone provides more than one word, we don't want to treat that as a string, but we'd like to treat that as a bunch of words, and you have to contain all of those words. So how would we do that? Add another variable. Yeah. Okay, so I don't. I mean, what if there's 3 words or 4 words or 50 words or? Yeah, the more, even more quickly we can do something. Yeah. Yeah. So let's split it. So now this is actually a list of words, and I don't know if we'll have to touch it up. Let's just make sure it's really clean. Let's make sure everything is stripped in there. So it's really a list of words with no spaces anywhere. Okay, now what?
If we're searching for bows and smid, do we want to return only the results that have both bows and smid in it, or ones that have either?
We can try either way, though more in almost every search system that I know, if you want, if you put in 2 queries, the default is that it takes the and of them, so it looks for things with both queries. If you wanted the or of them, typically you would search for bows and then you would search for smid. That gives you a little bit more, because some things will appear twice, but not the end of the world. But let's think about how we could get the end of all of these queries. So we don't want to have to change a ton of code here. Well, if I just change query into queries, then the whole thing is going to break. You mean like this? Then I'm asking, is this array or this list, is it in this string? And the answer is definitely going to be no, or it'll be an error. No, sets won't quite do it. Sets can only look for things that exactly match. All right, so let's start by saying that our results are, they're actually everything. Let's start by saying that our query result is everything, which is actually what should be the case if I search for nothing. If I just do a search and don't specify any criteria, then I should get everything, right? It matches all the criteria because there are none. Every record matches. And now I go through my queries and I use them to make the results smaller. So I have a set of results that I've computed so far. It's called results. And now I look in that set of results, and I'm only interested in the ones whose title matches. Or I'm only interested in the ones whose authors match, or I'm only interested in the ones who okay. So is that going to work? And you see why it works? Right? You start out and your list of results is everything, and then you go through and you take your first query term and you filter out anything that doesn't match that query term. Now you go through again, right? Results has now gotten smaller. It only has the things that match the first query term. Now you go through again, you take your second query term, you filter out everything that, that doesn't match that. It's smaller again. And then the next one is smaller again and smaller again and smaller again and so on. So let's try it. So there we go. Article with Bose and SMID. Article with Bose and SMID. Bose, SMID, Bose, SMID. And we get something else from this. That if we search for nothing, we get all 359 articles in the database. So we get the whole database. Okay. So there's a way to do these kinds of Boolean queries where you ask for things that that contain all of the search terms. Now, suppose we wanted to do these other kinds of queries where we want to take the OR. So how would we do that? So we'd like all the things that have both Bose or SMID. No. Well, the way I would do it is I'd search for the things that contain Bose, I'd search for the things that contain SMID, and then I'd put them all in a set. That would get rid of the duplicates. But it's not a common thing, and so we won't bother doing it. But there's a place you could use a set. So a little bit about this algorithm for querying this way. So what we did was we got a set of results, and we just kept making it smaller and smaller. There's a fairly there's some optimizations that sometimes happen here. So for example, if we search, for example, here's a way to make that slow. So if I search in, let's say, everything, and I search for so articles that contain all those things, still probably won't take too long, but, and Bose takes a little long, not terribly so. But this isn't a great, there's some optimizations that sometimes happen in these kinds of things where if we look at what happens here, we search for everything that contains that's almost all the articles, or yeah, 359 articles contain an A, and then we repeat that again and again and again and again. And so each time we're looking through 359 articles, which is not much, but imagine this system contained 100,000 articles. Then we keep looking through 100,000 articles, and the result is 100,000 articles because they all contain it, until we get to the end, and then we get these 40 or so. Articles here. Some of these systems will, if you were really making a system like this, you would find which of these terms is most important. In this case, it's this one, and I don't know if we'll notice it here, but notice that seems to be significantly faster to do it that way, because the first term gets us down to 48 results, and then we're only looking in a list of 48 results. But, yeah. So there's a slightly, you can notice a little bit of lag Maybe I can exaggerate it. There. That, there's a second that goes by there, whereas if I do it this way, there's no time at all that goes by. Okay. So back to this, this whole structure that we're working with. One of the ideas here was that we should be able to, for each author, make a list of the articles that they have that's associated with them. So have we done that now? Have we really created these author objects where the author has a list of all the articles that they've written? No, because if we look at the way all this works, ultimately, where do we make our authors? It's when we get this author list, and all we do is, for each name that's given to us, we make a new author object. So if the name, the author Pat Morin appears 100 times, we have 100 author objects whose first name and last name are the same. And maybe we'd like to not have that. So maybe we should fix that up a little bit and make a helper function that says make author. So we make an author with the given first name and last name. Now, what we'd like to know is, well, do we already have an author that looks like that? So what's the right data structure for that kind of thing, for that kind of test? So not only are we going to store a list of publications, but we'll store some information about our authors. And what kind of data structure should we use? A list. We don't want authors to appear more than once, so it sounds like a set or a dictionary, which is just has sets as the keys. So let's make it a dictionary. Okay. And so now when we make an author, well, we'll make this thing. And now we'll check if this author is in self.authors, then we don't actually want to use this new author that we've created. So in that case, we'll just return self.authors at auth. And otherwise, we've created this new author that we've never seen before, and so we'll say self.authors at auth is equal to auth. Okay. So we have this dictionary that takes authors onto themselves, sort of a strange way to do it. But the main reason we have it is because we have this nice set of we're using the authors as keys. It'll make sure that we never make the same author more than once. And all of that will work because author is a person, and persons have implemented equality by testing first and last name, and they've implemented a hash function that uses first and last name. So author inherits that, and so we should be able to do this. And now let's check to see how well we did. So we print information about the publications, and we can also print %d unique authors. Yep.
you still need to have a list of works that they've done. It won't just accept the first and last, remember?
When I did the make author function, yeah, I'm really regretting that decision now. Says it found 0 unique authors. Let's run that again. Found 0 unique authors. Okay, why? If author, add the author. We set it there. Let's do a search and see if we find anything. Well, there's definitely some authors being made. Oh, that's why we never called it. We want to do make author. Oh, sorry. Make author. And of course, it's self.makeAuthor. So that's 2 parameters, right? First name and last name. Oh, yeah, okay. I see what you're saying. Okay, found 696 unique authors, which is probably the right number. So we can look at b.authors for A and b.authors, print A. Looks good. Maybe it's it's a set, so everything in it is, or it's a dictionary, so everything in it is unique. So seems to work. Okay, so we'll leave it at there for today. Our next class is on Wednesday, and it's a little bit of cleanup and then review for the midterm.